With this video, I want to provide a little bit of background for the sampling lab that you're going to be performing in quantitative chemical analysis. So, as analytical chemists, we spend our time determining how to properly measure an analyte in a sample. And in order to properly sample, we have to know what it is that we're looking for and what it is that we have to work with. So, for instance, if we take the ice core collection over at the Byrd Polar Research Center on campus, as an example, they have a large collection of ice cores that they've collected from various glaciers, upon which they do some analysis. So in that case, the lot, or the total material available, would be a glacier. Now obviously you can't collect a glacier and store it in your freezer, so what we have to do is collect a bulk sample, which we use for archiving. And this is the ice core. The lab sample then is this small portion of ice, or the small sample that we actually do the analysis on. So how do we ensure that our lab sample is representative of the entire lot? It's really easy with homogeneous mixtures because, as you know, homogeneous mixtures have the same composition everywhere. Good examples of these are lab-made solutions or pure solids. And in order to analyze these, essentially we can take multiple aliquots or portions and analyze those portions. So for example, if we wanted to analyze this green solution, we would take maybe 5 milliliter portions and perform a measurement on those portions, and then find an average and standard deviation for maybe concentration of green dye in that solution. For heterogeneous mixtures, the analysis is a little bit more challenging because the composition of a heterogeneous mixture differs from place to place in the material. And there's a few examples shown here in the pictures. A chocolate bar that contains nuts and crispy rice and caramel, or some potting soil that contains various things, fertilizer and filler, or even in liquids where you could have two different polarity solutions or polarity mixtures or liquids present that don't mix well, and we can figure out ways to isolate our analyte. So if we think about solids, let's think about soil. Okay, one of the ways that we can better ensure we have a homogeneous mixture from our heterogeneous mixture is by grinding that sample. Make our pieces very small and try to get as close to homogeneous as possible. And some of the methods of preparation depend on what it is that you're looking for. So if we wanted to analyze our soil for metals, we could dissolve that soil in acid, which wouldn't destroy the metals present, and we could then analyze using various techniques. With liquids, if we wanted to look for a particular analyte, we could isolate that analyte by dissolving that analyte into a solvent that has a similar polarity. So we can pull it out of the solution that way. So there are various techniques for this. So in the sampling lab, our goals are to ensure that we're accurately representing the whole sample. So how do we do that? They're going to go through some exercises to help you figure that out. And you're also going to look at some exercises that help you determine the uncertainty in the measurement that come from sampling. And a lot of the things you're going to be looking at include probability. You're going to be measuring this or calculating this several times. You're going to figure out how to select the proper sample size, and you're also going to ensure that you're sampling an acceptable number of times. Okay, so hopefully this just gives you an idea of what we're expecting from the sampling lab and what you should take out of it. Thank you for listening.